Welcome to Regression Testing, brought to you by Group 9, Quaid Morrison, Zach Newell, and Foster Newfer. We will be covering what regression testing is, why we do regression testing, and a regression testing example. In this section, we will talk about what regression testing is. To start with, we'll talk about commandments and how they might apply to regression testing. In October of 1971, Richard L. Evans said, "Do you think the commandments should be rewritten?" And the answer was no, they should be reread. Well, does this have anything to do with software test? Should we rewrite our tests if they fail, or should we fix the software? Or should we ever run them again? This question of rewriting the commandments or changing ourselves is a good question. And the question of whether to retest, or are we being retested all the time, is a good question to ask yourself as well. What is regression testing? Regression is a test process applied after a program or a program's specifications are modified. Regression testing can be categorized into two areas: corrective regression testing, which is just code changes, and progressive regression testing, which is when both specifications and code are changed. Personal corrective regression. Let's compare our lives to a piece of software, and the commandments are the software tests. When we change ourselves, do we check ourselves against the commandments again? Yes. We recheck ourselves against the commandments again, or perform a regression test. Personal progressive regression. Let's do the same things again. Compare ourselves to a piece of software, and the commandments are our software tests. What about when the application of a commandment changes? For example, during the Old Testament, sometimes they were allowed to practice polygamy, and sometimes they were not. Do the scriptures or the tests get updated in the change of polygamy? The answer is yes. Do you still retest? The answer is yes. Regression testing. A change in me versus a change in the commandments. For corrective testing, the commandments are not changed, but we check ourselves against them, and then that could be as part of a reflection or maybe an interview. And it can happen in any interval as needed, but it may be planned out. And we always compare ourselves to the same commandments. For progressive testing, both the commandments and ourselves might change. There could be a very major change in our life. And it's usually done during adaptive and preventative maintenance. And we may need to reference new specifications, possibly conference talks. Let's look at corrective versus progressive testing from a software point of view. For corrective testing, specifications have not changed. There may be minor code changes due to development work or defect fixes, and the tests are reused as needed. For progressive, the specifications have changed. The code probably has changed as well, and the test cases need to change accordingly. After you have determined whether your regression testing is corrective or progressive, you need to determine how to decide which tests to run. There are two major strategies for test selection. The first is to do selective testing, where you choose only the tests in the areas that have changed. The second is to retest all. And there are benefits, of course, to selective testing because it does not cost very much. And you can usually identify which tests need to be run again. But there are times when you need to really look at retesting everything if there is a major code overhaul Or if you don't know how the changes affect the system, you may need to just retest all.
Now we're going to learn why we need regression tests in our software. First, let's get a quick summary of what regression tests are. Regression happens when old features in software break when new features are added. Regression tests are any tests that are added to the system which help catch this regression before our changes are deployed. These new features are deployed into their software system. So why do we need regression tests? It all boils down to the experience that we give our customers and stakeholders. Our customers and stakeholders are depending on us to deliver quality software. When new features are deployed, old features should continue to work as intended. When this is not the case, we lose our customers' trust. It is very important to keep the trust of our customers and stakeholders in order to deliver quality software. Regression has to be caught before the product reaches our customers to keep their trust. This means that all of the testing that is done leading up to software deployment has a purpose.
Let's look at a code example.
To better understand regression testing, we've included a code example. In this example, we have two functions, sayHello and sayWorld, which rely on a substring function to slice our initial message, hello world, into their corresponding parts, hello and world. Not knowing that Python implements its own version of the substring function, we've created our own that takes a string we'd like to slice, the starting index of the slice, and the end index of the slice. Because we want to ensure that our function works, we've written a unit test. On running the test, we can see that with the starting index 0 and the end index 4, we correctly produce hello from hello world. The test passes. Following this, we learn about Python's native method and decide to refactor our code to implement Python's method. Because our substring method is used multiple times in our code, and we do not know if other parts of our codebase relies on substring, we've chosen to update the implementation of our substring method rather than change everywhere it was used. Upon refactoring our code and feeling this was an easy change, we run our test only to find it unexpectedly fails. With further examination, we can see that in the Python implementation, the end index is actually the index that follows the last index of our slice. This is different from our interpretation of substring, which assumes the end index is the last index. Refactoring our code again, as seen in the second function on this slide, we run our test one last time and we see that our test passes. This is regression testing. Whenever we made a change, we kept running the test we made in the past to ensure that we didn't break any previous code. This example used a unit test. However, regression testing can be done with feature testing, integration testing, manually testing your code, or any form of testing you can think of. In real-world projects, you might see that many of these projects have large testing suites that get run every time a change is made to the code. By doing this, these projects can feel safe when they make changes and refactor code, because with well-written tests, they can be confident that they will know if anything breaks.